This is Dávid Juhász, and this is the first episode of Biostatistics Made Easy. In this episode or video, I'm going through the one sample t-test. Let's imagine the situation which I have written in my book. So I'm an imaginary bodybuilder who got into a conversation with his friend, a mathematician guy, who has doubts about whether bodybuilders are as tall as an average guy or whether they are taller. He states that they are taller. I disagree with him, and he's a person of numbers. So I have to prove my opinion in a statistical way. And now let's figure out which tests to use and how to carry out this task. First of all, we know that the conditions for normality are fulfilled. A, it's written down here. B, we are talking about heights which follow normal distribution. And also we've got one group of data which follows normal distribution and which needs to be compared to the expected value of the population. Easily speaking, to the average of the population, which is 175.5 centimeters. So what we can do is we can complete this three different ways. I'm going to show you the fastest way of them all, which is, first let's take a look at this average or this expected value here. We are talking about expected value when we talk about population. So we need to multiply this expected value. We need to make as many copies as the data set. So we need 15 average values, 15 expected values, which I can achieve by a Control-C, Control-V combination. I've got as many expected values as I have in the data count, so I have as many expected values as I need. And now I need to give the test statistic and the p-value for the test. The p-value of the test is generated by the T-test function. But here I need to give the array1, the array2, the tail, which is always two-tailed distribution, and the type here is even though we are talking about one sample t-test, I've made a pair for my original group. That's why I'm choosing paired. And in Excel, you can also see which part of the Excel function you're actually at if you take a look at this part, because the bold one is the part which you are in right now. So let's choose paired and let's close the bracket and let's hit enter. And now I've got 5.99%. Well, as I can see here, the level of significance is 5%, so I need to keep the null hypothesis and state that bodybuilders are not taller than the average height. Let's talk for a few seconds about the null hypothesis and alternative hypothesis. Null hypothesis is always a negative statement, so here it's about the fact that bodybuilders are not taller than the average height, so they are not taller than the expected value of the population. And the alternative hypothesis is about bodybuilders are significantly taller than the average height. So I've got the p-value, but I also need to write down the test statistic, which is T inverted, which is the probability, T inverted, two-tailed, and now I have to give the probability. The probability is what I have here, and the degree of freedom in the one sample t-test always equals the data count minus 1. So in this case it's 15 minus 1, so it's 14. And by closing the brackets, I finish the function, I hit enter, and I've got a test statistic too. And now I also need to write down whether I keep the null hypothesis or not. Let's write it down here. We keep the null hypothesis. Let's make a little bit more room for that. And as a result, if I keep the null hypothesis, which kind of error can I make? I can make the so-called grade 2 error or beta type of error, which is also frequently asked when you do such a biostatistical exercise. So as an extra piece of information, I'm writing down we can commit grade 2 error. And here we go. Let me highlight the results for you. Here we are, and we've successfully solved the exercise. I hope everything was clear, and feel free to watch all my other videos as well, because in the next episodes we are uncovering the 2 sample t-tests as well as all the other statistical tests that are written down in my book. So stay tuned and have a nice day.